everyone. Welcome to today's masterclass. I'm Josefina Insauti, Product Marketing Manager at ZIGURAT. Thank you very much for joining us today. So just a quick overview for those of you who may not know us. So ZIGURAT is an online institution. We have more than 20 years of experience in e-learning. We provide master's and postgraduate programs in architecture, engineering, and tech management. And our community is composed of more than 20,000 people from different countries, both professors and alumni. So you can see here a picture of our latest student week. So it's a very enriched and very motivated community we create here at ZIGURAT. So today's masterclass is related precisely with one of our programs, which is a postgraduate course in sustainable architecture. This is a 4-month program. It is completely online. And it gives you all the knowledge you need to understand and to implement sustainable practices in architecture. So you will cover reduced embodied carbon, life cycle assessment. We're going to see some of these topics today. And it's a very practical course. So in the end, you will give a project where you analyze an existing building and just devise a strategy to make it more sustainable. So you have the QR code. You can scan the code here and just see more details of the program. And without further ado, and I'll give the floor over to Olga and Julia, who are actually ZIGURAT professors. So I'll start sharing my screen and I'll hand it over to you. Thank you.
Let me share my screen. I hope you all can see it by now.
Yeah, we can see it.
Okay, so hi everyone. Thanks for joining the masterclass today, in which we will talk the key steps to a sustainable retrofit. The presentation today will be led by me and Olga. I'm Julia Galves. I'm a sustainability designer at Hawkins Brown, an architectural practice based in London. And Olga, I'll let you introduce yourself.
Yeah, hi. Thanks, Julia. So my name is Olga Barrachina. I'm an engineer and I'm a principal consultant at Strats, that is a consultancy located in Spain. And I'm specialized in energy efficiency in buildings and indoor environment.
Thank you, Olga. So the presentation will be split in 3 parts. First, we will dig into the whole life carbon. What is it? What is the impact of the built environment and the carbon emissions? We will understand what are embodied carbon and operational carbon and their impacts in the whole life carbon design. We will understand why retrofit is important in this scenario. And finally, what you need to look for when it comes to designing a sustainable retrofit in terms of both embodied and operational carbon. The second part of the presentation, we will comment some case studies, some of them being projects that we have worked on. Finally, we will sum up what are the key steps you need to take into account when doing a sustainable retrofit. First, I would like to set the scene. On the global greenhouse gas emissions, 39% are related to the built environment. And from this 39%, 11 is embodied carbon. The rest are other, including operational carbon. We, as professionals of the built environment, be it architects, be engineers, etc., we need to take responsibility in what we are designing because, as you can see, the impact we have is crucial. So you might be asking, what is whole life carbon? Whole life carbon are the emissions related to both operational carbon and embodied carbon. Operational carbon are the emissions associated with the energy we use to operate the buildings throughout its lifetime. It means lighting, heating, cooling, system, etc. This will be related to the source of energies as well that it's used. So for example, if it's a coal-based source, those energy used will emit carbon. But if it's a green source of energy, such as wind or solar, then it will not have impact on the operational carbon emissions. Regardless, we still need to look at the ways to reduce the energy use while the grid of energy that we have is not yet fully decarbonized. Embodied carbon emissions, on the other hand, are related to the actual material emissions. This from extraction of the material, manufacturing this material, the transport, installation, construction, maintenance, and finally, end of life. So to produce a brick, for example, how much carbon is needed to do that material? Then to take this brick to the site, is the site nearby? Is it taking an electric vehicle or is it diesel one? During the construction, will it generate a lot of waste? Throughout its lifetime, how many times do you need to replace this brick? And finally, at the end of life, will this brick be recycled? Can it be reused, or will it just go to a landfill? So these are the things that you have to bear in mind when it comes to embodied carbon. Now I will hand over to Olga, who explained the impact of these two carbon emissions.
Thanks, Julia. Well, now, after this introduction of when we are talking about the whole life of a building, okay, and carbon emissions, and then we said we have this operational carbon, it is embedded carbon. But if we analyze what's the relation that we have between these two different emission types of emission on a building, if we focus, for example, on the existing buildings, and especially those buildings that were built until the 20th century, we would see a relation that the one that we're showing in the slide, where the operational carbon is really important and has the maximum weight. Okay, that's why this explains why exactly all the new regulations, all the codes are focusing on this operational carbon, because all the existing building stock that we have nowadays, they have a really huge, big operational carbon emissions, which means that that's the first focus that we have to perform in our when we are trying to reduce the emission of the building. However, can you go to the next one, Julia? Thank you. However, what happens when we reduce this operational carbon emissions, because we implement in our buildings all that code regulation, all that improvements, which at the end means that we won't be consuming so much energy. So this means that if you can see now, this graphic here is showing that the operational carbon that will have this resulting building, it has reduced a lot. However, the embodied carbon is still the same that we had before. And now the weight that we have of the embodied carbon, it's much more important, which means that first we focus on the operational, but then we must focus on the embodied carbon as well, because the weight that it has on the whole life carbon of the building, it's important as also. Can you go to the next one, please, Julia? So now, what do we have here is that when we focus also on the embodied carbon, and then we have this embodied saving, and we have this operational savings, which means that it's the way that we at the end can really effectively reduce the whole life carbon emissions of our buildings. So maybe we can go to the next one, and we will see here, okay, we have here in this graph, the whole life carbon, okay, that we were explaining, it's operational and embodied. We have, I don't know if I can use a cursor. 1 second. Can I use, or you can use it because you are sharing the screen, Julia? Yeah. Okay. So if you can then maybe mark somehow. Okay, we have here this line that is an existing building that you can see that it goes up. So this graph here is showing during the time the whole carbon, equivalent carbon emissions that could have a building during this whole life. Okay, this is the line of the time, and then we have the carbon emissions. This existing building, where we have a building that maybe could have the usual renovations. That could be maybe we are changing windows after 20 years, and then we have new bathrooms, or we have a new heating system because it breaks, etc. So at the end, you can see that we are increasing through time the carbon emissions of the building. Okay, so what do we need to do? We need to decrease, okay, this carbon emissions. One solution could be the demolition of this existing building, because we have old buildings that, like we said before, they have really big operational carbon emissions because they demand a lot of energy because they are not well insulated. They have old heating and cooling systems. So maybe we could demolish the building and build a new one with the highest energy efficiency standards. What happens here? That at the end, we see that we have a line that is much lower than the line of the existing building so we have much less carbon emissions through the whole life of the building. However, this line, as you can see, is still higher than the lowest line that we have here, that is with the retrofit case. So at the end, what we see here and what has been seen through all these years and studies is that the most sustainable way to achieve this lowest carbon emission buildings is focus on retrofit and focus on deep energy retrofit of the existing building stock using low carbon materials. Yeah, can we go to the next one? So now once we have set this need, that it's clear that we are not, so the most sustainable path that we have is to based on the retrofit, on the deep energy retrofit. We can like list the main benefits that this deep energy retrofit would have. Okay, now okay, as I read that there is a question, maybe we'll do the questions at the end, right, Josefina and yeah, Julia. Okay, then we will do the question at the end. You can write them here on the chat, and then we can make some questions at the end. Okay, so I was saying, sorry, can you go back? Sorry, Julia. So I was saying, okay, let's list the benefits of deep energy. So some of them. We could list two different types of benefits. We have the monetizable benefits for building owners. Okay. And then we have all the benefits that are more public or more generic. They are not, you cannot monetize them. Okay. For example, on the blue ones are the ones that you cannot monetize. To have improvements in health and well-being, of course, but once you're deep retrofitting a building, then at the end you have a better indoor environmental quality. And then also reduce energy carbon, social equity, employment and growth, avoided energy infrastructure, and resilience, because we prepare these buildings to adapt to climate change better. And then if we go to the side of the building owner, they can monetize a lot of benefits like energy savings, or reduce maintenance and cost, increase rental income because they are improving their buildings, and also increase property values for the same reason. Okay, then we can go to the next one. So now, so we define the benefits, and now what we can, we will like explain very shortly the key items that you have to look when you are trying to reduce the operational carbon and also the embodied carbon. When we're talking about the operational carbon, the key items to look for is first the existing building performance, because you have to see how these buildings is, how much energy is consuming, how is the comfort inside the buildings, how are the users feeling, and how are they using the building at the moment. How is this constructed from a passive way to understand if there is insulation, there is no insulation, how are the windows, the infiltrations that there are, and how are the heating and cooling systems, if they are working correctly, etc. Then another key item, really important, once we have defined how is this my building now, how is it working, then we need to define this passive design strategies. So insulation of the envelope, how are the windows, so the performance of the new windows that we have to define, the air tightness, thermal breaches that we have to correct. Then third step would be the active design strategies. Once we have to work on the passive design strategies, then we define those systems, those heating, cooling, system ventilation that will assure that the indoor conditions are healthy, so that we have a comfortable temperature, comfortable air quality. And then also we will define those renewable energy on-site production that will assure that my building at the end is using renewable energy, and is at the end it's zero emissions or net emissions when we consider it, because we are used as much renewable energy as possible. And finally, a key item when we think about the operational carbon is the indoor environmental quality. Okay, because this is something that at the end we must keep in mind, that buildings are to be used by people, and therefore they need to be healthy, comfortable and healthy always. And now I'm going to pass the turn to Julia, because she's going to follow now.
Thanks, Olga. So on an existing building, when it comes to embodied carbon, what do you need to look for? First, you need to evaluate the existing building condition. As Olga was saying, we are now looking at the condition of the materials itself. Is the facade in a good state? Can we keep it? And as Olga mentioned, it might be that you want to improve the facade performance. So we might want to do that by increasing the insulation. So on the existing building, what can be kept? Ideally, we would like to retain as much as possible, especially those big ticket items when it comes to embodied carbon emissions that are a structure and the building envelope, the fabric. Also, in the existing building is also very interesting to do a pre-demolition audit and understand what is there and what can be reused. What are the internal finishes that can be used? Is the raised access floor in a good condition and can be kept? What about the lighting fixtures? What about the glazing at all? So that's everything that you already have. You have to see your building as a livestock of material and see how much you can use the most of it. But obviously keeping in mind, as Olga said, the performance of the building as well. So it's always a balance. Finally, if you do need to add new materials, because that will happen. So as the example, as I just said, of insulation, then you need to start thinking, what is the most sustainable alternative? Is there a recycled option for insulation? Is there a reused material from another site that you could use? Or is there a natural material that is a viable options? So these are all the things that you always have to keep in mind when you are doing a design of a sustainable retrofit. Now, I'm going to move on to some case studies. The first is the building Uno in London by Hawkins Brown. This is still in deconstruction stage. That's what we call nowadays. We don't want to say demolition anymore because, again, as I said, everything should be seen as a potential material to be reused. So this is a project I'm currently working on as the whole life carbon assessor. Ever since the beginning, the client had big aspirations when it comes to sustainability. So retaining as much as possible of the existing building was key. The building is split between a 1800 listed Victorian facade here, this part of the building, and the back bit is an extension that came after from the 1990s. Because we decided to keep all the structure, we're able to retain 96% and do an extension, a lightweight, in which we didn't even have to reinforce the existing foundation. The initial plan, though, was to retain the 1990s facade here and just reclad it, because we also, as said, we wanted to improve the fabric performance. The way that it wasn't viable in terms of energy use. However, when we were doing the analysis, we realized that to reclad the facade, that would mean that we would need to add more support structure if we just took out the facade and did a new one. So basically, by recladding, we would have more embodied carbon than redoing it. I know that it feels counterintuitive, but that sometimes happens. And that's something that we always need to analyze when it comes to whole life carbon, is always a balance between embodied and operational. Therefore, in this part bit here, in the bit, we decided to do a GRC, new facade. And together with the facade engineer, we worked closely with them, and we were able to reduce also the support structure to make it more efficient as possible. So in the end, the embodied carbon of the facade ended up being quite low of what it could have been. Another quite interesting thing that it comes to circular economy and reuse is the fact that this extension on top, we were able to reuse 5 tons of the existing steel structure that we had from the existing building. There was a roof of the existing building. We cut out this steel structure and reused it in here. So that was also a very important key item in terms of saving embodied carbon. And finally, as I mentioned before, raised access floor. These are very high intensive embodied carbon materials because it's basically a metal plate. And there was some in this existing building because it was also an office. So we have stored it and we're going to reuse that. All these measures allow the building to avoid almost 6,000 tons of CO2 compared to a new building. And also by improving the building fabric, we also reduce the energy consumption from the existing building by almost 68%. Moreover, the building now will be 100% electric and will have a renewable energy source. This other building, the Utopia, is a project by Archetype, another London-based office. It is located in a local conservation area in the historic Cambridge city centre. The project goals were to achieve a deep green retrofit that maximized energy efficiency and minimized embodied carbon impacts at the same time. Again, it's always about a balance. A fabric-first approach was taken into the design strategy to fulfill the EnerFit standard. EnerFit standard is the passive house certification, but focused for retrofit building. So it's a bit more loose than what a passive house would be. Therefore, it was prioritized the reduction of energy demand through a very efficient fabric. The strategy from the beginning was to insulate the solid brick walls internally because it was a listed building in a conservation area. However, the single glaze existing sash windows needed to be replaced. And this would mean a potential change of appearance. However, by adding this triple glaze windows with improved thermal performance and the way that the windows are done, so with the recessed frames and lack of the sash bars, it actually also improved the daylighting levels. So Archetype and the design team, they were able to persuade the planning committee, in that case, to prioritize the sustainability over conservation. So that was a key win. And moreover, the finishes, furnitures have been selected in a circular economy principles. They have reused lighting fittings, and they have reclaimed secondhand carpet and furniture. And they claim that these measures have saved around 84% in whole life carbon compared to what would be a business as usual retrofit. So it's a very interesting project. I'm going to hand over back to Olga now.
Thanks, Julia. So I'm going to present 2 more case studies that are also another type, 2 different types of renovation. They were both done here in Spain in this case. So now this is the renovation is part of a live project that has it's a European it's an European funded and it's called Renatural Concept Project. And the focus of the project was to analyze the use of natural materials for deep energy renovation. Okay, and this example here is a neighborhood, residential neighborhood in Badajoz. It was so it's a whole neighborhood that was built at the same time during the 60s, the 1960s era. And it's, as you can see here, it's 800 residential buildings. Okay, there are houses. Some are like the houses that are all together, are not isolated, but they are not whole buildings. Okay, so they are buildings isolated. They are not. Sorry, I don't know now the word, but they are not like a building with different households in the same, like a tower. Sorry. Okay. Anyway, so what was the idea of this project? Okay, they wanted to perform this deep energy renovation, focusing on NZEP regulation code. That it's a directive, European directive. The European countries, we must now focus all the new buildings or all the renovation. They must assure that they are net zero energy buildings. That's what the initials NZEP means. Okay, and then what they try is that they said, okay, we're going to do this deep energy renovation using natural materials, local natural materials. Like, for example, they use cork insulation on the facade. It was like a sate, but it was performed with cork. And then they use also lime plaster as a finishing material. Also, they put new windows. They were with windows and some other materials. They were not. They were also. Of course, they also changed the heating and cooling systems. But now we are focusing here only the passive part, because that's where they were using these low carbon materials that are the natural materials, the local natural materials. At the end of the renovation, what they had is that they had improved the indoor environmental quality, not only because through this deep energy renovation, but also due to the materials that they use, the natural materials. They had a reduction of the operational carbon because these buildings were high energy efficient, and also they had a reduction of the embodied carbon. Okay, because they were using during the renovation these natural materials, local natural materials, which, like Julia said, okay, they are a good choice when you're trying to reduce the carbon, the embodied carbon. And can we see the next one? Yeah. And this is another example. This is a tertiary building. This is an office building in Madrid. This is a project I worked on as well. And this building, so they kept the structure. So it was deconstructed, like Julia said, not demolished, it was deconstructed. They kept the structure, but then what they did is that they added a new facade. Okay, and this building, it was designed also looking for following the high energy efficiency codes and regulations that we have now, which means that there was a higher reduction of the operational carbon. But then when designing the facade, the curtain wall, they try to look for this local wood for the shading, and while using this local wood, what they achieved is that there was a reduction of the embodied carbon of this 42 tons of CO2. Also, during the design, there was an improved in their environmental quality, because with the shading and the design of other strategies, we were showing high levels of comfort of the users through the whole year, not only in winter, also in summer, which in Spain, for example, it's really critical in this kind of buildings. So maybe we can go to the next one. Yeah, also, after these 4 different case studies that we presented you, now we will go to the end. So the conclusion is we will go to list these key steps to sustainable retrofit. And we summarize them, we organize them in 3 main stages. First, we say, okay, the first stage is when, okay, you want to perform this sustainable retrofit, you have to evaluate the existing building. And first, it's really important, as I said, to understand the current building performance, how much energy is consuming at the moment, and okay, all the operational carbon that it's emitting. You need to understand this building and see how is it performing. And then
once you understand in terms of operation, and you also need to understand what is this existing building, how much of it can you retain, how much of the materials that are in the building can be reused. And again, it depends on the performance of the building. The facade might be good, but it's not performing like in terms of appearance, but it might not performing as good as it should be in terms of operational. So this first step is to actually gather your existing building, evaluate what is happening, what you have there, and how much you can improve out of it.
After this first step, after this first stage, what we have is this second stage, but we have this improved energy use. And then here we have these 3 different steps that this first approach. But we were talking about insulation, air dryness. I was talking about these passive strategies, because we want to reduce how much energy is demanding the building. And then the next step would be also, as we said, to define these efficient systems that will assure that there is comfort inside our building through the whole year, which means heating, cooling, ventilation, and then also all this renewable energy that we will have on site, because we want that our building will use as the maximum renewable energy as possible. And after these two stages, we have the final one, that is to choose these new materials wisely, that it's more related with the embodied carbon point of view. And then we have these 3 steps, that it's embodied carbon considerations that we have to keep in mind when we are thinking about materials. And like Julia explained before, recycled materials or reused materials preferably. And also keep in mind the carbon factor of these materials we are choosing. Then it's really important also to look for healthy materials, because at the end, the indoor air quality is also really important. And as we said, buildings, we are designing buildings, and they have to be used by people, and they have to be comfortable but healthy as well. And finally, it's the long life of this new materials that we are using, and that they have to be robust, and they have to ensure that they can be an easily replacement if they need to be changed through their life. And well, finally, there is this sentence we wanted to, that would, maybe it's a little bit long, but the idea is that what we wanted to share with you is that at the end, the integrated low carbon assisted energy retrofitting of building is key to fight the climate change. So we have to keep in mind, not only is operational carbon, it's also embodied carbon, and it's a balance. And we need to have a whole picture and make a holistic, integrated assessment to understand which are the best solution in each case. So that would be all. Thank you very much. I think there were some questions.
Thank you. Thank you very much, Olga and Julia. It was a very interesting overview of the retrofitting process, both with theory and also with practical examples. So thank you very much. Yes, we have a couple of questions here in the chat. So let's see, Guillermo Ortega says, can you share the definition of low carbon material?
And I see there is a second bit of international standard to measure carbon emissions. So we would go in further details throughout the course, but in terms of low carbon, when it comes to materials, we have one thing nowadays that is becoming more and more common in the industry that is called EPD. It's Environmental Product Declaration. The EPD is a document that will tell you from a certain material how much carbon is needed to create that material. So we use that. And usually comes with different units, but usually it's kilograms CO2 by a certain unit. Usually it's kilos, but it could be square meters, it could be cubic meters. It depends on the material, the supplier. So, and that's what we use when it comes to low carbon materials. If you want to define, is a material that to be produced, it has lower embodied carbon.
Is there an international, well, you just mentioned this, right?
Yeah,
Sorry.
it would be the EPD.
Okay, the EPD. And then, well, this is the same question, but Parves, he says, how can we measure carbon of a retrofit material? I don't know if this is the same or is it a different part of the process? Or is this the same?
So we didn't go into the details of the life cycle of a material. Again, we will go into more details throughout the course. But when it comes to, imagine if you are reusing a material on site, what we're going to do is we won't take into consideration the emissions to manufacture that material, nor the transport if you are using that in the same site. But you might consider what is the emission that this material will have later in its life cycle, so either replacements of this material and the end of life emissions.
Okay, and then Anna Viana says, I understand incentives and regulations are key to allow this kind of retrofit projects, right? How do you see this playing outside of Europe? Thank you, great masterclass.
Well, outside of Europe. Yeah, that's clear. I mean, many countries have already, they have a lot of code and regulation. And I see that something that, I mean, many countries now are using this. For example, I know that in Saudi Arabia, that now there is a lot of construction going on. They have all these kind of regulations now, and they are focusing on operational and embodied carbon, all this regulation also, because they want to build a high efficient building. Of course, they are building new. They are now building new. They are not retrofitting. Regarding the retrofit, maybe there are not too many regulations, but I think United States, also in South America, there are. I mean, some countries are, many countries, in fact, are now seeing this need because. So I think it's not only Europe. No, it's 40% of energy emission are coming from buildings around the world, which means more or less 40 or almost true. So which means that all the countries, they know that to fight climate change and to fight emissions, they need to make regulations on this, on the operational, but then at the end, it will come also the embodied carbon.
Okay, and then we have a last question from Parves. How can we make a comparison of old and new retrofit material?
I think it's similar to what I just replied. So basically, if you want to compare a material that it's reused, it's almost like you don't consider the manufacture bit, especially if it's already on site. So it could be even that it's more than 50% less carbon emissions. It really depends on the material, if that material will be replaced throughout its life cycle as well.
Great. So I think we don't have any more questions. No, that's it. Okay. So thank you very much, Julia and Olga. Thank you everyone for joining us today. This session is being recorded, so you will receive via mail a recording of this masterclass. So here Michael says hi from Brazil. And Julia here is from Brazil, actually.
Yes.
So thank you very much for joining us. Thank you both for this masterclass. And please, if you want to know more about this, if this interests you, we have a question here from Marianne. Okay. Marianne, do you want to open up your mic, or you just want to drop the question in the chat? Let's see, wait a minute. Here, I've opened up the microphone if you want to speak. Marianne, can you, let's see. Can you open up your mic, or you can just drop the question in the chat as you wish. No, I think she just left. Okay. In any case, just check out the course, or you can send us an email and we'll get back to you. So thanks again, Julia and Olga. Thank you everyone for joining us, and hope to see you next time.
Thank you very much. Bye.